October 2020. The U.S. Commerce Department adds a Chinese semiconductor manufacturer to the entity list. The stated goal: cut it off from the tools it needs to make advanced chips. No U.S. software, no U.S. equipment, no exceptions without a license almost never granted. 5 years later, that same company's chips are inside phones sold in 9 countries. That's not a leak. That's not a black market shipment hidden in a container manifest. That's retail distribution, invoiced, taxed, sitting on shelves. Here's the part worth sitting with. Nothing about the export control failed mechanically. The restriction did exactly what it was designed to do. SMIC never got access to extreme ultraviolet lithography machines, the ASML-built systems that cost roughly $200 million each and remain the only tool capable of printing circuits at 5 nanometers and below in a single pass. That control held. It's holding right now. And SMIC built 7 nanometer class chips anyway. Not with EUV, with deep ultraviolet lithography. Older, cheaper, originally built for larger process nodes, run through the same silicon wafer 4, 5, sometimes 6 times instead of once. Multi-patterning, slower, more expensive per chip. Lower yield, meaning more waste per good unit produced. Commerce didn't fail to see this path. They judged it commercially irrational, too costly, too slow, not worth pursuing at scale. That judgment is where this story actually lives. Because in August 2023, Huawei launched the Mate 60 Pro with a Kirin 9000S chip built on SMIC's N+2 node, the multi-patterning workaround, running in a facility that was supposed to be starved of exactly this capability. Teardown analysis confirmed it. No foreign fabrication, no smuggled die, made in China under sanction, 4 years after the designation took effect. The commercially irrational math changed the moment the buyer stopped answering to shareholders. A state doesn't need a factory to turn a profit. It needs the factory to exist. Beijing didn't need SMIC's yields to compete with TSMC on cost. It needed proof that dependency on foreign fabrication could be broken at any price, and it was willing to eat the price difference indefinitely to get there. That's the fact most coverage of this story keeps missing, and it's the thread I want to pull on today, because the 9-country shipment isn't the headline. It's the confirmation of something that was already true and just took the rest of the world a few years to notice. The number worth remembering for now: 4 years. That's the gap between the restriction taking effect and the restricted chip shipping internationally, at volume, under a different company's logo. We'll come back to why that gap matters more than the chip itself. Start with the mechanism, because the mechanism is where the export control theory quietly breaks down. DUV multi-patterning isn't a secret technique. It's the industry's oldest workaround, dating back to when EUV didn't exist yet and everyone used it. The physics is straightforward enough to explain in one pass. A single DUV exposure can only resolve features down to a certain width before light starts to blur past its own wavelength. So instead of one exposure, you split the pattern into 2 or 3 layers, expose them separately, and stack them with nanometer-level alignment. Miss that alignment by even a few nanometers, and the chip is scrap. That's the trade-off. You can get to advanced nodes without EUV, but you pay for it in time, in wasted wafers, and in a much higher chance that any given chip comes out defective. Industry estimates on SMIC's N+2 yield have varied, but multiple semiconductor analysts placed it well below what TSMC achieves at equivalent nodes. Some put it under 50%, meaning close to half of what goes into the process doesn't come out as a usable chip. TSMC's comparable yields sit closer to 90%. That gap is the entire ballgame. It's why Commerce assumed this path wasn't worth walking. On a spreadsheet built around unit economics, it isn't. Here's the case study that makes this concrete, and it's not the one everyone already knows. In late 2023, SiCarrier, a Shenzhen-based equipment maker almost nobody outside the industry had heard of before that year, began quietly supplying deposition and etching tools to SMIC's expansion lines. Corporate filings later traced SMIC Carrier's ownership back through a Shenzhen state investment vehicle, not a private startup chasing a market opportunity. A tool built, funded, and timed by the same government that added SMIC's customers to its own countermeasure list. This is the part where the story stops being about one defiant company and starts being about an entire domestic supply chain assembled specifically to backfill what the entity list removed. Wafer equipment, etching tools, deposition systems, one designation at a time. That's the open loop from part one paying off. The 4-year gap wasn't SMIC alone grinding through low yields in isolation. It was 4 years of a state-directed equipment ecosystem maturing in parallel, each piece slotting in as the last foreign supplier got cut off. Compare that to the U.S. counterargument, because it deserves the space. Commerce's position was never China can't build any advanced chip. It was China can't build them at a competitive commercial cost, at meaningful volume, indefinitely. That's a real distinction, and for smartphone-grade production, it's mostly held. Huawei's Mate 60 shipments were constrained, not abundant, in their first year. The gap in that argument is what happens when the buyer is willing to subsidize the inefficiency forever, because the goal was never margin. It was sovereignty over the process. A company chasing quarterly earnings walks away from 50% yield. A state doesn't have quarters. The chips now reaching 9 countries didn't get there because SMIC solved the yield problem. They got there because the buyer redefined what counted as success. Now, the part that complicates the clean version of this story, because it is cleaner than it should be, and clean narratives are usually missing something. The state absorbs the cost forever argument has a ceiling. Subsidizing 50% yield on a smartphone chip is one thing. Subsidizing it across an entire economy's chip demand is another. China's Semiconductor Self-Sufficiency Fund, the so-called Big Fund, officially the China Integrated Circuit Industry Investment Fund, has moved through 3 phases since 2014, with the 3rd phase launched in 2024 at roughly $47 billion. That's a real number, and it sounds like proof of unlimited commitment. It isn't. It's proof of a bet, not a guarantee. Big Fund's first phase saw several of its executives investigated for corruption in 2022, including the fund's president. Money moving toward a goal and money moving toward outcomes are 2 different things, and China's own anti-corruption apparatus has spent real effort establishing that gap exists inside this program specifically. So here's the reversal. The 9-country shipment looks like a triumph of industrial policy. Sanctioned company, restricted equipment, global distribution anyway. But the chip actually shipping in volume to those 9 countries isn't the bleeding-edge N+2 smartphone processor. Trade data and component teardowns through 2025 show the bulk of SMIC's international shipments are older generation chips, automotive-grade, IoT-grade, power management silicon, the unglamorous high-volume parts that don't need EUV, don't need multi-patterning, and were never actually blocked by the sharpest restrictions in the first place. The flagship 7-nanometer chip proved the capability exists. The 9-country shipment proved the capability could scale, but mostly at the node ranges that were legal to build all along. That distinction matters more than it sounds like it should. It means the story isn't sanctions failed, China builds cutting-edge chips freely now. It's narrower and, honestly, more interesting. Sanctions failed to prevent capability from being proven, while continuing to functionally cap how much of that capability turns into volume at the leading edge. SMIC can make an N+2 chip. SMIC cannot yet make millions of them profitably enough to flood a market, the way it floods the market with legacy nodes. I'll admit, where I'm less certain. Public yield figures for SMIC's most advanced runs are estimates from research firms like TechInsights and Bernstein, not confirmed by SMIC itself, which stopped breaking out advanced node figures in its own earnings disclosures starting in 2022, itself a data point worth noticing. The company that wants you to believe it's succeeding is also the company that stopped showing its work at exactly the moment the world started asking harder questions. What's verifiable is the direction, not the precision. Every independent estimate, Bernstein's, Tech Insights, SemiAnalysis, places SMIC's advanced node output as growing year over year since 2023, even while yield stays depressed. Growing from a low base is still growing, and a policy built to prevent growth, not just cap efficiency, has to reckon with the fact that the line on the chart is going up regardless of what it costs to get there. Pull the threads back together because they were never actually separate. The entity list did its job in the narrowest sense. No EUV machine ever reached SMIC's fabs, and it never will under current controls. But export controls were designed around a single assumption, that cutting off the best tool would cut off the outcome. That assumption held for private companies chasing margin. It didn't hold for a state chasing proof of concept, willing to burn money on a 50% yield line to demonstrate the line exists at all. That's the 4-year gap from part 1, closed. Not 4 years of failure, 4 years of a government building the equipment ecosystem, SMIC and the rest, to make an economically irrational process politically survivable indefinitely. My read on this, for what it's worth, the West has spent 5 years arguing about whether sanctions worked or failed, and both camps are answering a question that was never precise enough to answer cleanly. Sanctions worked at capping volume. They failed at capping capability. Those are different victories and different failures, and most of the policy conversation still conflates them. Here's where I'll stake something concrete. Watch SMIC's disclosed capital expenditure over the next 18 months, not its chip announcements. Announcements are theater. The Mate 60 launch was timed to a U.S. Commerce Secretary's visit to Beijing, which is its own kind of message. Capital expenditure is the number that can't lie about whether Beijing believes the yield problem is closing or just being subsidized past. If SMIC's advanced node capex keeps climbing while yield estimates from outside firms stay flat, that's a state still willing to pay for symbolism. If yield estimates start closing the gap with TSMC, that's the moment the commercially irrational workaround stops being a workaround and becomes a competitor. I don't think we're there yet. I think we're at the point where the tool works, the state will keep paying for it to work badly, and the rest of the world has to decide whether badly, but scaling is a problem for next year or a problem for right now. The entity list didn't stop a chip from being built. It just changed who was willing to pay for it, not to matter that the process was worse. That's the whole story, if you're looking for it in one sentence. If this kind of tracing, export control on paper versus what actually ships, is useful to you, there's more of it coming.